Welcome back everyone. Today we're going to be looking at section 1.6, solving absolute values. Absolute values, in case you don't know, is the distance from 0 on a number line. That's what an absolute value will be telling us today. If you've never seen an absolute value, they have straight lines or straight bars right around a number. To solve or evaluate an absolute value, you just really want to look at a number line or think of a number line and figure out how far away from 0 you are. So for example, the absolute value of 4, you would go to 4 on your number line and see how far away from 0 it is. So if you count, it's 1, 2, 3, 4 away from 0. Same idea if you have the absolute value of -4. Go to -4 in your number line and count how far away from 0 you are. So 1, 2, 3, 4. How about you guys try? What would the absolute value of 2 be? Or in other words, how far away from 0 is it? Well, if you look at your number line, 2 is just, 2 away from 0. How about you guys try, what would the absolute value of -2 be? Or, in other words, how far away from 0 is it? Well, very similar. If you count, it's just 2 away. Or I'm sure some of you guys are noticing some patterns. If you have a positive number, it just stays positive. But if you have a negative number, it turns positive. Okay, so that's how you evaluate using like a single number on a number line. But we're going to kind of look at something a little bit more challenging. We're going to be looking at equations. So let's check our first example. All right, so our first example, we have the absolute value of 2x minus 1 equals 5. So kind of going back to these number lines, there's really two ways you can be 5 away from this absolute value. You could be at -5 or you could be at +5. So when you're solving an equation, you're going to split up your equation. So you're going to copy what's inside the absolute value that doesn't change. You're going to set it equal to the positive, and you're also going to set it equal to the negative of what it equals. Because really what you're doing is, if you go back to the number line, you're going to figure out what would set it to the left side of 0 and what would set it to the right side of 0. So there's really going to be two possible answers that would make this true. So we're cut off just a little bit there. So this first one we would just solve like we normally would. You would add 1 over, and you would have 2x equals 6. And then our last step would just be to divide. So we would get x equals 3. How about you guys try this second equation? What are you going to get is your solution? Well, if you've tried it, first thing you probably should have done is add the 1. You'll get 2x equals -4. Divide the 2 over, and you'll end up with x equals -2. One thing that's really important with absolute values is that you really do need to check your answers. We'll talk about it in a little bit why, but if you don't check your answers, sometimes it can come to bite you in the butt. Even if you solved everything correct, it's just something you need to do. So for example, to check our first answer, we'll check 3. So we're going to just take our original equation, and we're going to plug 3 in for x. So we would have 2 times 3 minus 1 inside our absolute value. And we want to see, does that equal 5? That's our question. So if we work this out, kind of like working inside of parentheses, 2 times 3 is 6, minus 1, that would just be 5. Well, is the absolute value of 5 5? Well, yes, of course it is. That 5 is 5 away from 0. How about you guys check the second answer we got? We got -2. So if you plug it in, this is what it'll look like. The question is, does this equal 5? Well, assuming you check this, well, 2 times -2 is -4, minus 1 would be -5. Does the absolute value of -5 equal 5? Well, yes, it does. -5 would be 5 away from 0. All right, looking at our second example, sometimes you might have an absolute value equation where you have stuff outside your absolute value. One thing that's really important before you split up our equation like we did in this first example, you need to get the absolute value piece by itself. So it's kind of like if you're solving an equation, you always want to deal with the number not with your absolute value. So we would start by adding this 1 over. So we would have 9 on the other side. And then this number in front, this is 3 times this. You don't want to distribute or do anything like that. To get rid of a number in front, you want to divide it to the other side. So we would have the absolute value of x plus 2 equals 3. Now we can split it up into our two equations. So we would have x plus 2 equals positive 3, and we would have x plus 2 equals negative 3. So these are pretty simple to solve, so we can just subtract the 2. So we would get 1. We can subtract the 2, and we would get x equals -5. For the sake of this video, oops, sorry, that was cut off on the bottom there. I'm going to pause. I'm going to show you that if you do plug these in, they do work, but you should check your answers. All right, so the video is going to jump. I went ahead and I worked out x equals 1. You'll see you do get it to equal 8 in the original equation. If you plug in -5, you will also see you get 8. So if you want to try and work it out on your own, but just trust me that it does work. You're probably asking, why do we have to check our answers, Mr. Swope? I don't want to do that. That's doing too much. Well, the reason is when you're solving absolute value equations, sometimes you can get something called an extraneous solution. Basically what this is it's a false positive, or it's a solution that you'll see that is really not true. So even though you did all your math right, if you plug it back into the original equation, you're going to see it's not true. So looking at our first example, we have the absolute, oops, this got messed up. Here, let me rewrite this, and I apologize for the video. But it would be the absolute value of 4x plus 10 equals 6x. So it's already, the absolute value is already by itself, so we're ready to split it apart. So we could do 4x plus 10 equals positive 6x. And we could do 4x plus 10, well, the opposite of 6x, or it would be negative 6x. So we're going to solve these two equations. Sometimes it can be a little bit tricky because we have variables on both sides. But like I said, if you have x's on both sides, my advice is get rid of the smaller of the two. So in this case, it would be the 4x. So we could just subtract that to both sides. So we would have 10 equals 2x. Divide the 2. You'll get 5 equals x. For our second equation, the smaller of our x's, well, in this case, we'd probably want to still move the 4x over. So if you do that, you'll end up with 10 equals negative 10x, because negative 6 minus 4 is negative 10. Divide both sides by negative 10. You'll get negative 1 is x. But are these truly our solutions? Let's check them really quick. So if I plug 5 into this original equation, I'm going to have the absolute value of 4 times 5 plus 10 equals 6 times 5. You plug it into both of these x's. So if we work this out, this would be 4 times 5 is 20. plus 10, that would be 30. So we have the absolute value of 30 equals 6 times 5 is 30. Well, that's true. But let's look at our other example, and I'm sure some of you guys are seeing this probably won't work, or why would I be wasting your time? But if you plug in -1, you'll have the absolute value of 4 times -1 plus 10 equals 6 times -1. So if we work this out, we're going to see that the absolute value would be -4 plus 10. Well, if you have a calculator, depending on your mental math, that would be +6. And 6 times -1 is -6. I mean, is the absolute value of 6 -6? Is 6 on a number line -6 away from 0? No, it is not. So this is not a solution. So we basically would cross it out. So the only answer to this original equation is this one. So it is possible when you get your answers that one of them could be false. So that is why I'm telling you need to check your answers. Lastly, keep in mind that absolute values can never equal a negative number. That doesn't mean you can't get negative answers, but if you have an equation where an absolute value equals a negative number, that's a no-go. You're going to write that there's no solution. So for example, this question here, I have the absolute value of 3x plus 4 equals a negative number. Well, that's impossible. You can't be -3 away from 0. So this would be no solutions. If you did, and if you really want to see if this is true or not, if you did split this up and do like 3x plus 4 equals -3, 3x plus 4 equals +3, if you went and you solved these and plugged those values back in, you should see that both of them are extraneous. So it'd be a lot of time for not much result.